Hello, everyone. Thank you for joining this Tech Talk. We're going to talk about running Spark applications using EC2 Spot Instances on Amazon EMR for the purpose of cost optimizing your Spark workloads. My name is Ran Scheinberg, and I'm a solutions architect for AWS. I specialize on Spot Instances. That means that I work with customers on cost optimizing their compute workloads across various types of workloads and use cases. For example, applications running on EC2, containerized workloads. I talk a lot about Kubernetes and ECS and how to run Spot instances for the underlying infrastructure in those containerized kind of applications. And of course, I talk a lot also about analytics workloads, big data, and how to cost optimize Spark, Hadoop, and other applications on EMR and with other orchestration tools. Let's see a little bit of what we're going to talk about today. We'll do a quick recap of EMR and how it could help your organization crunch data, run ETL workloads using Spark. A lot of what we're going to talk about today addresses Spark specifically, but can also be applied to other tools in the Hadoop framework. We're going to talk about the node types and purchase options. Those purchase options will take us directly to Spot instances. When we learn about Spot instances and how to use them in the right kind of using the right kind of best practices, we're going to see that flexibility and diversity of Spot instances is one of the most important best practices to achieve scale and to achieve resilience. And with that in mind, we're going to talk about how to right size your Spark executors in order to allow for that flexibility. I'm going to do a demo on how to run an application, a Spark application with EMR using Spot instances, and then going to show you some more resources. We have a hands-on workshop that can help you learn how to do everything that I'm going to show you today, and a blog post that dives deeper into resilience and how to run Spark applications on Spot with EMR. And let's get started. So EMR is a way we allow AWS customers to run managed clusters of the Hadoop framework, the Apache Hadoop framework, and Apache Spark frameworks. This allows customers to avoid the heavy lifting of installing, maintaining, upgrading the applications you need to use in your analytics and big data pipelines. Some of the benefits of EMR is that it allows to scale compute and storage independently. So you can use your data, you can put your data on S3 instead of thinking about putting it on inside your cluster in HDFS, and that way you can scale your compute to achieve a lot more higher performance and finish your jobs in a shorter amount of time. EMR makes things a lot simpler in that it allows you to, with a few clicks or within your automation pipeline, set up your desired version of Spark, which is what we're going to focus on in this presentation, and just start crunching your data and running your Spark applications without thinking about the undifferentiated heavy lifting of everything we mentioned before. EMR works ideally with S3, which allows for high durability, and using EMRFS, it allows you to, like we mentioned, decouple the compute from the storage. EMR allows you to monitor your cluster. It's tightly integrated into CloudWatch and the rest of the platform. You can use the console to view the job history and browse logs, so it really simplifies the way that you're going to troubleshoot your jobs. And there's also on-cluster HDFS for the data persistence layer in case you need to run HDFS in your Spark applications. This could be for several reasons, like performance, but we're seeing a lot of customers having a lot of success with the data lake approach, where the data is just located on S3 and the jobs are ran against S3 directly. Let's have a look at some of the benefits of using EMR with Spot instances. But before we get into those, let's see some of the other non-Spot related benefits. So the first one is automation. Because EMR, like every other AWS service, is available programmatically via the CLI or SDK, you're able to fit it into your data pipeline, into your analytics or data crunching or ETL pipelines, in that you can start your clusters or submit your jobs to EMR programmatically. We're seeing a lot of customers doing this with AWS step functions, CloudWatch events that trigger Lambda functions, or with third-party tools which are really popular, such as Airflow. So EMR fits into your data pipeline, your with the right type of automation that you want to use for it. It's tightly integrated into the rest of the AWS platform, in that, like I said, you can fire up your jobs with CloudWatch events and Lambda. You have a lot of important metrics that EMR automatically sends to us to CloudWatch metrics. We have EMRFS, which allows to work in a resilient way against S3 to avoid working with HDFS and decouple the storage from the compute. Um, and it's current. EMR has updates within 30 to 45 days of when the actual Apache Hadoop or Apache Spark updates versions go out. And so with a simple change of the API version of the version of EMR that you're going to call with your API, you're getting the latest versions of the tools that you're going to use. So that makes it a lot easier to not think about upgrading your Spark applications when you just want to test out new Spark versions, when you know you want to use some new feature in Spark. And every Spark version has typically a lot of new features and bug fixes. So within a click of a button, within a small change in your API call, you can use the latest version of Spark in order to get started, test your application code on a new version, and switch your production data pipeline, your ETLs, into the new version with much ease. What's relevant to Spot instances with EMR is the elasticity and the low cost that you're seeing on the right-hand side. So in terms of elasticity, EMR allows you to scale, with the power of EC2, you can, with a click of a button, get a lot more resources to run your compute. Spark inherently is able to handle much more scale and to parallelize the way it works on your Spark application. So it's super easy with EMR to just achieve more scale, run more EC2 Spot instances, which will run your executors and your tasks for your Spark application. We're going to see that in the demo later on. And of course, low cost. There's a very strong integration between EMR and Spot instances via the instance fleets configuration option. This allows you to diversify the Spot instances that you're going to use to achieve more resilience. And we're going to show this in the demo as well. If you think about the scale point, think about when you're running a job with 10 instances for 10 hours. If you can achieve 10 times that scale with EC2, with the underlying infrastructure that's going to run your Spark executors, you're going to actually parallelize the job and cut down the execution time from 10 hours to 1 hour if you're running the 10 times the amount of compute. So just think about how this allows customers and organizations that are moving from on-prem to the cloud to really cut down their time to insight, cut down the time it takes them to run those ETL jobs, and achieve much higher scale, meet their SLAs with just this ability to parallelize their jobs. If we're going to run Spot instances as our Spark executors, is the instances inside our EMR clusters, let's give a gentle reminder of what are the node types inside of EMR. So we have the master node. This is the node that manages the cluster, tracks the status of tasks and the health of the cluster. And for example, in Yarn, this is going to run the Yarn resource manager and the name node for HDFS. In the case of core instances, this actually runs the HDFS data nodes. So in case you are looking to use HDFS for your jobs, this is where the HDFS data will be located. EMR allows for elasticity in this node type, so you can increase and decrease those instances without having a lot of heavy lifting of resyncing the HDFS cluster yourself. EMR does that for you. And the place where Spot instances really shine is the task nodes. Because HDFS doesn't run on the task nodes, they're much more elastic, so it's much easier to just add compute to the task instance fleet, and that will just run more Spark executors for you without thinking about the HDFS cluster and needing to resync and re-add or remove instances to the HDFS cluster. So the task instance fleet will only run your Spark executors, and this will allow you to achieve much higher scale to decrease the time your jobs run. So choosing whether you're going to run on-demand or Spot instances in each type of these node types really depends on the use case, on the work, and on the workload. We have a lot of customers running their Spot clusters strictly on Spot instances. And if you think about it, a lot of the ETL jobs take a few hours, and the chances of getting interrupted, if you select the right instance types, the chances of getting interrupted are low. Depending on the instance types that you're going to select. So we have some customers even running the master and core nodes on Spot instances, but the common use case for production workloads is basically to run your master and core nodes on on-demand instances because they are not as fault tolerant or resilient as the task nodes, and then scale with Spot instances on the task nodes. This would really depend on the use case and the type of workload and your SLAs that you're going to achieve, but definitely experiment with the way that you run Spot instances in your cluster. Maybe for your non-prod environments, you can run strictly on Spot instances, and then for production environments, run a small set of core nodes on on-demand and scale on the task nodes with Spot instances to achieve that the deep savings. And with deep savings, this takes us to Spot instances. Let's talk a little bit about what they are and how we're going to use them within our EMR cluster. So EC2 has several purchase options. The first one, where most customers start with, is on demand, where you pay by the second, and this is where customers start to define their needs, or when they have spiky workloads. Most customers will be using this default launch option, purchase option of on demand. When customers are running steady state workloads such as databases, or even in the context of what we're referring to, maybe Kafka or Spark streaming instances, where it's steady state, it's running all the time, customers can commit to a 1 or 3 year commitment and receive a significant discount over the on-demand prices. And then the third purchase option is Spot instances. And Spot instances are actually the spare EC2 capacity that we have. And we allow customers to leverage that spare capacity at discounts of up to 90% of the on-demand prices. Spot instances are most useful for fault-tolerant, flexible, and stateless workloads. That's because Spot instances can be interrupted with a 2-minute warning when when EC2 needs that capacity back for on-demand. So if you think about running big data workloads, and the way that Spark is inherently resilient and will retry interrupted work that has been interrupted in the application, we can start thinking about how Spot is a great fit for Spark workloads. And we do see a lot of customers being very successful with running Spark on Spot instances using EMR. The way we see that customers succeed the most with Spot instances is being able to be flexible with the instance type that they're going to use, and we're going to dive much deeper into that later on in the presentation. But for now, I want to show you one of the case studies that we have for a customer that achieved hyperscale over 1 million vCPUs with Spot instances, and they did that by diversifying to many different instance types across several availability zones in the region where they were running. And this is Western Digital that has been doing millions of simulations on the future of how the hard drives head are going to how they're going to innovate on the heads of the hard drives. And they, with that scale, they were able to decrease their time to results from 20 days to 8 hours. Granted, most customers don't need clusters of 1 million vCPUs, but this just comes to show how it's possible to achieve huge scale by diversifying to multiple capacity pools. And we're going to explain capacity pools in this next slide. If we look at a region that has a C5 and in three availability zones in different sizes, this is just an example, so the prices and the t-shirt sizes aren't necessarily relevant, but we have a lot of families, so this is just an example of an instance family inside a region. And we know that each instance family in each one of the instance sizes, or the t-shirt sizes as some people like to call it, within each availability zone, and this is true for every region, is a separate spot pool. So think about running an application and being able to support multiple capacity pools in order to tap into more capacity, right? If you're just going to run a single instance type, then you're limited by the spot capacity for that specific instance type. But if you are able to work in multiple availability zones, or work with multiple instance families and multiple instance sizes, you're actually tapping into a lot more spot capacity. And if you're running your cluster on multiple capacity pools, you're actually decreasing your blast radius. So if some of that capacity gets interrupted, either your job will start on other instance types, or in other use cases, only a small portion of your job will actually be interrupted if you're diversifying. You're probably thinking about how EMR starts a cluster always in the same availability zone. So this is still true. I'm going to show you how with EMR instance fleets, you are going to supply multiple capacity pools to EMR and tell it to just select the best capacity pool for the job in terms of available capacity and price. But the EMR cluster is still going to start in a single availability zone. And if you're thinking about, okay, today I'm using a specific instance type for my Spark executors because I sized the Spark executors to fit it, I'm going to show you how it's possible to still supply multiple capacity pools in order to increase the resilience of your Spark applications. We have a couple of great customer examples that are using EMR with Spot instances today, and Salesforce are actually, running a lot of their iterative jobs on Spot instances and reporting savings of up to 90%. They're actually improving the digital personalization experiences and insights to their clients using EMR, and achieving that deep cost savings. Zillow are actually running Spark, Hive, as well as Scoop on EMR using a mix of on-demand and Spot for their ETL analytics and also machine learning workloads. So we have a lot of customers cost optimizing their EMR Spark workloads, and these are just a couple of interesting examples we have on the website as well. So what are kind of the simple rules of Spot instances that you need to keep in mind when you start adopting them? The infrastructure itself is the same as on-demand NRIs. This isn't just the old servers we have lying around in the basement. This is the latest and greatest, and all the instance types we have running on-demand are available as Spot instances. So there's really no difference in terms of the infrastructure or the hardware between Spot instances and on-demand or reserved instances. Spot is just a purchase option. The spot pricing is typically would be around 70 to 90% off the on-demand price. And if you used spot instances up until a year and a half ago or 2 years ago, before we made the pricing changes, you know that we used to have spikes in the pricing. This is no longer the case. So today, the spot prices change infrequently. There's no spikes. So the prices are much more predictable, and the price changes according to long-term supply and demand in each of those capacity pools that we mentioned. So the prices today are much more predictable. In terms of interruptions, you cannot get outbid like you used to be able to 2 years ago. The only reason why your spot instance will get interrupted and would get that 2-minute warning is if EC2 needs that capacity back for increasing the demand of the on-demand in that instance type, in that availability zone. So the way to think about handling those interruptions is being able to run on multiple capacity pools, and I'm going to dive deeper into that and how to do that with EMR instance fleets later in this tech talk. And this diversification comes in similar ways in different types of workloads. Think about a front-end web application. I would like to run my application on multiple instance types within the same cluster, within the same ELB. So if some of that capacity gets interrupted, only a small portion of my instances are impacted. So my application keeps on running. I'm still meeting my SLA. I'm still being able to process my users' requests. And auto scaling group, for example, would replenish the capacity I need when some of the instances get interrupted. It's a bit different with EMR, as EMR would still select a single instance type or try to select a single instance type for my run, but it will be able to replenish that capacity, my target capacity for the job, if some of it gets interrupted by EC2. Just a quick look at how our pricing used to look until late 2017. For those of you who has used Spot for a few years, are familiar with the spikiness in the pricing, and we changed that in order to allow for smooth pricing changes. And this is an example from the last few months of an R4 8XL. In the US East 2 region, there are hardly any price changes. Only one of the availability zones had some small changes over the course of 2 weeks within 1 or 2 cents. So prices are much more predictable today, and you don't need to think about those pricing spikes. Another important tool for you to know is the Spot Instance Advisor, and this would actually allow you to select the region and the operating system that you want to use, and we even have a checkbox for only showing instance types that are supported by EMR, and this would actually show you the frequency of interruption over the last 30 days. So it allows you to make smart decisions regarding your Spot instances, and being able to select the right instance types for the job. If your job isn't fully fault tolerant, you would want to go for instances with lower chances of being interrupted. And this actually shows you the last trading 30 days and the frequency of interruption per instance type in the region we selected. So let's talk about those interruptions. Statistically speaking, we know that over 95% of the instances of the Spot instances globally were not interrupted in the last 3 months. So that means that less than 5% of Spot instances globally actually get interrupted. So Spot instances do get interrupted. We want you to be resilient and to architect for fault tolerance and statelessness. But it's important to remember that it's not like your Spot instances are going to be interrupted every few minutes. And when you start using Spot instances with EMR, you'll actually find it very easy to track whether or not Spot instances are getting interrupted or whether or not your jobs are completing on time. I'm going to show you that EMR actually targets the right capacity pools with the most capacity in order to try to decrease those interruptions even further after you select instance types with lower interruption rates. You can think about the work that you're doing to make your application fault tolerant also benefiting Spot, right? We want your application and your architecture to be cloud native. We want to architect for fault tolerant applications without single points of failures. And when we talk about kind of EMR workloads or Spark workloads, Spark is pretty much a fault tolerant application in that it will repeat the work that was interrupted or failed on the cluster. So this is a really a great fit for Spot instances. It's not really stateless in a way that it does obviously keep state on the instances and in memory, but it is fault tolerant in that it's able to repeat work that has been lost due to an interruption. So a Spot interruption could cause your Spark application to take longer, but in a lot of cases, if you target the right instance types and are resilient and flexible in how you configure your EMR cluster, it might take a bit longer to complete the job, but it will complete eventually. And if you do configure your EMR clusters for multiple instance types, EMR is just going to replenish the interrupted capacity in order to continue the job. I'm going to show you how to do that later on. So I'm talking about multiple instance types in an EMR cluster, and for that we need to be able to be flexible with the size of the executors. Let's dive a bit deeper into what that means. So the problem is that when we run our Spark applications, the Spark executors have a uniform size, right? I'm going to show you an example in a minute, but we actually set up the number of cores and amount of memory that we want our Spark executors to consume from the instance. And a lot of times, when I talk to customers, they tell me that they have been using a single instance type with on-demand for a long time, or they're actually migrating from on-prem, and they're pretty static with the way that they set up their Spark executors. So the applications are actually the result of that is that the customer would want to run their Spark application on a very specific instance type that fits their needs. And that means that they will not be able to be flexible with the types of with the instance types that they're going to use in the EMR cluster. And if you're unable to be flexible with the instance type that you're going to use, you won't be able to achieve that those benefits that we mentioned before, right? Tapping into more capacity pools and being able to replenish the capacity if your selected instance types will get interrupted by EC2. So what's the solution here? If you're using a very large executors, you can decrease the size of the executor many times, but still keeping the same ratio of CPU and memory. This will still allow the tasks to complete their job, but you might be running more executors on your cluster, which is perfectly fine because we're increasing our flexibility and our resilience, and that just means that you need to be flexible with the instance types that fit the vCPU and memory requirements. Let's have a quick example. So let's say that today, either in on-prem or we're using EMR today, we're just submitting jobs with 16 cores. We're requesting 16 cores from the instance types that we're going to use and 72 gigs of memory. The problem is that this really limits us to instance types with very high amount of memory. And if you know that Spark actually EMR would actually limit the size of the executors with the Spark configuration, with the YARN configuration of memory overhead and other static configurations that keep some memory for the operating system. So we would actually be looking at a relatively small number of instance types that we can use. Some of the times, those larger instance types with a large amount of memory would have higher Spot interruption rates. So if we're able to decrease the size of our executors, we would actually be opening the door and tapping into a lot more capacity pools with lower interruption rates. And generally speaking, as a Java best practice, just to reduce the garbage collection time, you would want to keep your Java memory to your JVM size to around 20 gigs, where it would take a long time for GC on executors with 70 gigs of memory. So keeping that in mind, if we keep the same ratio of executors to of cores to memory in the way that we run our executors, we can see that we can decrease the amount of memory and the number of CPUs to four vCPUs or 16 gigs of memory, and that would kind of fit a lot of our R family instance types or I3 family instance types. So then we would be able to, increase our utilization of how we use those instance types and be very flexible, because EMR with dynamic resource allocation would be able to run more executors on larger instance types, and be able to be very flexible with the instance types that you're going to use. Just tell EMR to select any of the instance types that you're able to use for your cluster, and EMR will go and fetch the right capacity to run your Spark applications. Let's dive a little bit into that before we show this in the actual console. So if you're familiar with EMR uniform groups, which is the initial configuration option, the default configuration option of EMR, you know that you have the master, core, and node node types that we talked about before. But this gets a lot more interesting with EMR instance fleets, which is kind of the newer configuration for EMR, and that has a much better fit for spot instances, in that you can specify a target capacity as a mix of instance types, and you can specify up to 5 instance types. That means that instead of talking in the amount of instances that I want for my cluster, I can actually tell EMR how much each instance type is worth towards my target capacity. And I can just know that I need, okay, for this job I need 500 cores or 500 vCPUs to run my job, and I'm going to just tell EMR to fetch that capacity of possibly a mix of instance types, or just select the right instance type for the job. So this allows for much more flexibility. When I specify multiple instance types, EMR is going to select capacity from the deepest pools where we have the most capacity, in order to decrease the chances of EC2 Spot getting interrupted. And it will also select the cheapest instance type from that selection. When spot instances would get interrupted, or when EC2 instances fail, because instances fail as well, it's not just spot interruptions that we need to think about. EMR is able to replenish that capacity and just replace the interrupted or failed instances with one of the other instance types that we specified. So here we're really increasing the resilience of our EMR cluster. We might be sacrificing a bit of our performance, because we are going to not work with the ideal instance types with maybe we have been qualifying or optimizing for some time now. But by increasing that flexibility, we're allowing ourselves to save up to 90% by using spot instances. So that increased flexibility is really important for our cost savings purposes. And Spark is really inherently resilient, so your application will actually continue to run if some of that spot capacity gets interrupted, or if any of the instances fail. And I do recommend that after this, after going through this webinar and looking at some of the other resources that I'm going to show you later on, like the hands-on workshop that we have, you do go ahead and test some of that. Running some of your EMR work, your Spark applications on spot instances, and seeing whether or not you're getting interrupted. And if you are getting interrupted by EC2 with your spot instances, you see how your job will complete. It might take longer, but you will be tapping into very deep cost savings with using spot instances. Great, so let's get to the demo part, and I want to show you how to run a Spark application using EMR with EMR instance fleets and spot instances. So this is the EMR console. I basically just clicked create cluster, and these are the basic configuration options, the quick options. I will want to go to the advanced options just to make sure that I show you all the relevant things for our demo. I'm going to stay with the latest and greatest version of EMR, and I just want Hadoop Spark and Ganglia on my cluster. I'll use Ganglia maybe later on for some monitoring purposes. And I do want to add a step that will be submitted when the cluster actually starts. So to configure this, I just have my configuration on the side. Um, I'm going to run it in cluster mode, and the executor memory is going to be 18 gigs, and the number of cores will be 4. This is a great fit for R4, R5 instance types, where I'll have very good utilization of those instance types. And if I run larger instance types from that family, Spark and EMR are actually going to run multiple executors on the larger instance types. I do have a small Spark application that I'm going to use against an Amazon data set, a public data set. I can show you that application code. It's within our hands-on workshop that I mentioned before that I'm going to show you later on. But this is basically very simple application code that goes to the Amazon reviews public data set to the Parquet format and just does a word count on it. So nothing too fancy, it's just for demo purposes. And then I am going to put my results in S3, and if we'll have time, we can actually show the results with Amazon Athena. It would be very simple to query my actual results. So I'm going to submit this step when the cluster actually starts, and I can auto terminate the cluster. For the purpose of transient cluster, a very popular option for customers running EMR and Spark as part of their data pipeline, as part of their DAG, to just bring up that cluster for the sake of the job, running it for a couple hours on spot instances, and then terminating the Spark cluster, this transient Spark cluster, when the work is finished. So like I mentioned before, the default configuration option is uniform instance groups, but we're going to focus on EMR instance fleets. What I'm going to do is select multiple availability zones in my VPC, actually all the availability zones that I have in my VPC, all the subnets actually, and I'm going to do that to allow EMR to tap into all the capacity pools across those different availability zones. Now, when I'm going to select my multiple instance types, as I mentioned before, EMR is going to look across those instance types and across those availability zones and choose the best capacity pool to run my cluster. So I'm going for the purpose of this demo, I'm going to run the cluster entirely on Spot instances, and my master node is going to be an M5XL. And now I can start selecting the instance types that fit my executor size in my core and task instance group. So for example, in my core and task, I can select a couple of R4 sizes, a couple of R5 sizes, and maybe put in the mix an i3 instance as well, because I know it has the same vCPU to memory ratio as my actual as the actual R instances. I'm going to do the same for my task group, just because I know that this already works for me. But of course, in terms of the ratio of memory versus CPU, other things might work for you. I'm going to show you how where we have some data on how to optimize that sizing. And let's see what we have here. For example, in the task fleet. So I specified 5 instance types. And now I'm able to specify the spot units that I need. So for example, if I put 40 units here, each instance type counts as the specific number of units towards this spot capacity. So instead of talking about the number of spot instances that I want, I can talk about, in this case, the number of vCPUs that I have that I will have in my cluster, because EMR by default configures each instance types to count as the number of actual vcores, yarn vcores that translate into vCPUs in each of those instance types. So an R5 to Excel 8 has 8 vCPUs. Those are actual 8 yarn vcores, and this would count as 8 units towards my target capacity. Whereas an R4 extra large has 4 vCPUs. Those are 4 vcores, and it counts as 4 units towards my target capacity. So that means from this selection, EMR is going to select the best capacity for running my application, the deepest pools where the instances are least likely to be interrupted. And if it chooses an R4 Excel for this job, then I will get 10 instance types because I specified 40 spot units with and this instance type is worth 4 units towards my target capacity. And if the one of the larger instance types like R52XL or R42XL is going to be selected, I will get 5 instance types for my job. For my core units, I just want a very small footprint of core instances because they're mandatory for when you using EMR instance fleets. So I can just specify 8 spot units, and I will either get one core unit because it will select the R52XL, or 2 units if it will select one of the smaller instance types. Some of the other options I have here with Spot Instance Fleets is to run a Spot Block. Spot Block is a spot of defined duration from 1 to 6 hours. It comes with a lower discount compared to Spot Instances, but this is actually uninterrupted capacity. So if you know that you're going to run a Spark application which is not fault tolerant, it needs to meet a very strict SLA, then you can try to use spot blocks for your workload. But bear in mind that the discounts are much lower with spot blocks. And because the EMR is going to target the deepest pools with the least likelihood of interruption, you might want to start from running your jobs without spot blocks and only going to spot blocks if you really need to meet strict SLAs and you see that you cannot handle those interruptions in your Spark application. Another interesting feature is if instructing what EMR should do if it's unable to get that spot capacity that you configured in the cluster. So after a configurable amount of time, it can either terminate the cluster or switch to on-demand instances. And again, if you need to meet an SLA for your job, if it's a part of the data pipeline, you might still want to pay more by running those on-demand instances. But if you're well diversified across multiple instance types and you're able to be flexible with the instance types that are going to run your jobs, in many of the times you'll be able to get that spot capacity and run your cluster. But it is great to have those provisioning timeout options as well. And that's basically it. My hardware for my cluster is configured. I'm going to have one master node running on an M5 Excel. Eight 8 spot units are requested for the core instance fleet, and EMR is going to select one of those instance types to run it. It will either run one large instance or 2 small instances. And the same for my task group. My task instance fleet is going to have higher scale to run more executors, and I'm going to run multiple executors on the larger instance types, or a smaller number of executors on the smaller instance types. Let's continue with the configuration. I'm just going to give a tag to this cluster so I'll be able to easily see it in the console, and this would be Tech Talk Demo 2. And I won't dive into security because this is outside of the scope of this tech talk. I'm just going to create my cluster. Just for the purpose of time savings in this tech talk, I already created a very similar cluster before. Let's go into EC2 and see what kind of instance types were selected for the previous cluster where I had very similar configuration. So this is the cluster I set up before. Let me just filter according to that name. And right now I'm sorted according to the instance type, and I can see that the M5 Excel was selected as the master node. I can just have a look at the tags, and I can see that the instance group role is master. So I only specified one instance type for my master node, and that was the M5 Excel. I actually specified in my previous cluster AMD instance type, so the R5A. Those would be AMD instances, and these were selected as my core instance types. And then for my task instance fleet, I initially started the cluster with R5 Excel. Some of those instance types got interrupted, and then EMR replenished from R5 to Excel. So basically, I can see that EMR was able to handle those spot interruptions. And actually, this cluster has been running for a few hours. But if my if my Spark job would have lasted a few minutes, like it is with the current job that I'm running, then I would not even be able to see those interruptions happen, because the job would have finished before, and my cluster would have been torn down before. So this is the cluster that I just showed you in EC2. Like I mentioned, it's running 8 units for the core task group, for the core instance fleet, and 40 units for the task one. And the step was actually completed in 7 minutes. This is the step that I submitted for the task, the step that I showed you when I started the cluster. And that's basically the way to configure an EMR cluster with EMR instance fleets for this increased resilience and flexibility. Being able to supply multiple instance types for my cluster will enable EMR to select the deepest pool to run my capacity on, and enable you to be a lot more resilient in how you run your Spark applications. Once the job completes, it's going to have a very simple word count, and it's going to put those results on S3. Before we finish up and get to questions, there are a couple more other resources that I want to show you to enable you to take away from this session. So we do have a very nice landing page in the Spot website, that allows you to see some of the customer use cases that we have, and some interesting videos on setting up EMR clusters that will show some of the information that we just shown in this tech talk. Some of the other resources that we have here is a deep dive blog post on how to run Apache Spark on EMR with Spot instances, and it has some very interesting examples and ideas on how to increase resilience, and also an online workshop, a self-paced, hands-on workshop. So in terms of the blog post, we have a lot of interesting things here. We touched on some of those here, for example, sizing Spark executors, but we also have some other advice here, such as avoiding large shuffles, and how to, actually dive deep into your Spark code and make it more resilient. And in terms of the hands-on workshops, this is where you can see the workshop, EC2SpotWorkshops.com, and this is actually a self-paced, hands-on workshop that will guide you through some of the things that I showed you in this tech talk. For example, right-sizing the executors, the required step for selecting the instance types that will be a good fit for your Spark application, and eventually even analyzing the cost savings that you achieved with Spot instances when you run your EMR cluster. And with that, I want to thank you for joining the Tech Talk today. This in this link that you'll be able to see in the Tech Talk page as well, you'll be able to see the videos and all the information that we have on running EMR with Spot instances for deep cost savings on your Spark workloads. Thank you, and I hope this was educational, and that you'll be able to achieve cost savings for your Spark applications.